Once a scientist has collected data, they need to organize it so it's easier to analyze. Setting up a chart or graph makes it easier to see patterns in the data so they can draw accurate conclusions. By the end of this lecture, you should be able to create an appropriate chart for a set of data and decide whether a line graph or a bar graph is most appropriate. A table is a way to organize data so that it is listed in two columns. It is easier to make a graph if you first arrange your data into a table. Each of the columns need to have a title at the top, which includes the units that the data was measured in. The left column of the data chart is for the independent variable, and the right column lists the corresponding dependent variable for each data point. The data table at the bottom was created after a scientist did an experiment answering the question, how does human growth hormone affect growth? Each subject was given a different amount of human growth hormone, or HGH, and then their height was measured. Since the scientist was giving hormone to the people, this is the independent variable. They measured the height of the person because this was the effect they were interested in seeing, so this is the dependent variable. Notice the top of each column lists the units in parentheses. The second data table organizes data about where a group of students who go to Kennedy live. It's harder to pick the independent and dependent variable in this case, but here's why the town is the independent variable and the number of students is the dependent variable. I specifically chose which towns to survey, and based on what town it is, there's a specific number of students who live there. In other words, the number of students I find in a town depends on what town I'm looking in. It would be silly to say that depending on how many students live there, I know the name of the town. So just because there are 15 students living in a town, I can't necessarily call that town Baldwin. But because I'm looking at the town of Baldwin, I can count 15 students who go to Kennedy who live there. So the town is my independent variable, and the number of students is my dependent variable. Now that we've made data tables, we can create our graph. There are two main types of graphs that scientists make. The first type of graph is a bar graph, and the second type is a line graph. If the independent variable is continuous, a line graph is most appropriate. So what do I mean by continuous? Well, you need to ask yourself, is it possible to have data points in between the data points I collected in my experiment? If your answer is yes, then you should create a line graph. If your answer is no, then you should create a bar graph. On the last slide, my first data point was for giving someone 0.5 milliliters of human growth hormone. And my second data point was giving 0.8 milliliters of human growth hormone. There are values that I can imagine in between 0.5 and 0.8. So my chart should be a line graph. However, in the second chart, you couldn't say that there are values in between different towns. Each student lives in either Baldwin or Chesterfield or one of the other towns listed. You wouldn't say that you live in between Baldwin and Chesterfield in some unnamed town. So when your independent variable falls into distinct categories, your data should be arranged into a bar graph. When creating a bar graph, there are some important things to know. First of all, it's easier to read your data if you use the entire page of your graph paper. Secondly, all bar graphs and all graphs in general need to have a title. So in this case, I gave the graph the title number of students. Also, all graphs begin at the point 0, 0. In the case of a bar graph, we don't have values along the x-axis. We have distinct categories. But in a line graph, you should always start at 0, 0. Here on the y-axis, I did start with the point 0. The independent variable goes along the x-axis, and the dependent variable goes along the y-axis. In a bar graph, you should always create your data points so that the largest comes first, and they decrease as you go to the right. So always looking at your independent variable, which one is the greatest. The y-axis is the one that goes up and down, and the x-axis is the one that goes across, if you haven't learned that in math class. So now you try. For each of these sets of data, I want you to create a data table, and then simply state whether the data should be graphed using a line graph or a bar graph. You don't actually need to create those graphs.